Okay, so let's see if that works. Still completely unfamiliar with OBS Studio, but yeah, it looks like we are live. Okay, recording working, audio working, camera working, so we can start. Oh. Okay, so why do I make a second video after my stunning success, attention sarcasm, with the hot air station last week? So this is basically part 2, and I try to finish this SMD Soldering Practice kit. I've changed my camera setup, so that's now just my smartphone running, what's the app called? DroidCam OBS with the OBS plugin, and I think the video quality should be a bit better than last week, I hope. Okay, so maybe let me summarize everything I did wrong last week. So first thing I did wrong was I used the wrong nozzle. I was using the smallest one. And obviously smaller diameter and means higher airflow when you don't change the airflow on the station. So this is basically giving you with the same settings on the Atten, gives you a gentle breeze, and this gives you a quite big storm on your PCB. And the second mistake I made is I was using too low temperature. I set it to 300 or 350 degrees. And in hindsight, I'm already using 350 degrees on the soldering station. So that means, this is direct contact. If you use the soldering station and touch a pad, then you get your 300 degrees on the pad. But if you use a hot air station, you have to go higher. So ask a few people, ask a bit around, and they told me 400 degrees is quite normal, maybe even higher when you have a PCB with a lot of ground planes. So as you can see, in the last stream we basically did these 3 rows. What was this? The 1206 resistors, the 0805 capacitors, and the 0805 resistors. And then I was, playing a bit on my own without the camera, and I did the row with the 0603s, resistors, capacitors, and with the 0402. The 0603 and the 0603 I did with the hot air station. The 0402 I did with the soldering iron and the tweezers, because I don't think you're supposed to solder 0402s with a hot air station. I mean the default setup for a board like this would be use a stencil, get your paste on, and then put it in a reflow oven or on a hot plate, and just wait for the solder to melt and everything to reflow. What was working quite well was putting these 2 chips on. I basically just tacked 1 pin and then basically just put a string of solder paste here on the pads, heated it with the hot air station, and this is more or less the result as it looks like after reflow. Of course, cleaning up the flux with IPA afterwards. That was working quite fine. So the whole reason for this exercise was to fix my true SDX build, which is basically a small ham radio transceiver, which I've completely destroyed, more or less. I don't know. It had a few problems from the factory, cold solder joint, and then I came with my soldering iron and made things worse and not better. So in the end, the result was I get a hot air station and try to sort it out. Not cost effective, but it's a new toy, and I think it's I'm already getting used to it, and I'm getting better. So the one thing that I broke was the SI, what's it called? SI 5351A. It's commonly used I2C VFO chip. And as you can see, you can get these things here on a dev board like this from eBay, and it has 3 clock outputs, power controlled via I2C, very popular device. And it used to be soldered on here. And what I did is I used the hot air station to take the defective chip off from my true SDX. I took the working one off from this dev board and swapped them out. Well, not swapped, because this is the defect one, so I didn't put that back on here, but just to give you an idea of the size. Maybe, let's see if I can zoom in here a bit. Yes, I can zoom. Fantastic. This works much better. And I can get the board here. And this is the chip. And yeah, it's really fiddly, so I think when you are a god with a soldering iron, you can do it, but the hot air station makes it really, really much simpler. You just heat the thing and, you know, grab it with the tweezer. So taking chips off with the hot air station is really, anybody can do that. And for putting back on, I have to train a bit more. So in the end, I hand soldered the chip back onto my true SDX with a lot of flux, which was also working. But I guess with a bit more practice, I could also do it with a hot air station. So let's zoom out again. Oops, maybe like this. Okay, and is it focused? Nobody knows. I think so. Okay, so right, a lot of talk, nothing happened yet, and I've probably already lost the 0 viewers I have. No, nobody's watching, but maybe it's useful in a replay. So I'll just keep recording this and finish it, and then I've, you know, done it once, and yeah, might be the last live stream ever. Okay, so back to the SMD soldering kit. So as I told you last week, NE555 to create a clock signal goes into this CD70, what was it, 4017 counter, and the counter counts and basically, you know, switches these LEDs on one after the other. And I think the one on the on this output pin are the 4 LEDs that go here in the corner. Good. So the question is, do I use the hot air station again, or do I just SMD solder these bits? Good question. I think for the LEDs, which are in this plastic housing, I will hand solder them, and the rest I will try with the hot air station. So let's see how that goes. Good, so let's zoom in a bit on my piece of art. Move it a bit. Yeah, that should work. Now we have to figure out, I guess we'll start with the 2 capacitors. Start with some small bits, so C27 and C28. I think here and here. And yeah, I don't know. Well, it's an experiment. I don't think any sane person solders individual capacitors and resistors with a hot air station, but let's try. Maybe I have improved since last week. So getting a bit of, no, first, that's my APA. Clean off the pads a bit. Hoppala. That was my cap for the IPA bottle. Anyway, I'll need more APA, so just leave the cap off. So clean the pads a bit. And then the solder paste. Oh, I have to be gentle. Too much is not good. And it's also still hot. Maybe I should preheat the PCB a little bit. Yeah, see, it's already too much. Okay, that is already too much, but let's try. Maybe I've improved since last week. So now get the SMD capacitors out. Come on, you bugger. Number 1. And number 2. Don't shoot across the room. And then place them. I'll rotate the board now. Okay. Ooh, bloody hell, I'm shaking today. Not good. Getting old. And the second one. I'm not sure if I should place them both. But let's see. Let's try with higher temperature this week and maybe, I don't know, 40% airflow or so, but don't know if that is a good idea. Did I put them at the right place? Yeah. Switch the hot air station on. Go to 400 degrees, maybe 45% airflow. And yeah, now I'm left-handed and the cable comes out on the left side of the machine. I should have placed it on the other side of my desk. Let's see, how can we do this? Yep, I'll get it here, but it's a bit stretching. I'll move it a bit to the left. Okay, powering up. Gets hot. Let's see how I'm doing. Yep, I'm already doing bad again. You can see I really need to place the hot air station somewhere else, because I can't hold it straight directly blowing from the top. But I think I was working a bit better than last week. Let's have a look. Eagled eyes. And maybe it's hard to say. Maybe not enough solder. Let me have a look. Yeah, but I think it's okay. It's not so bad. It reflowed, it centered itself, so I think that's okay. So next part would be, I should mark them off. Yeah, that's always usually a good idea if you build a kit or so. Get a print out of the PCB and tick off the components you put on or cross them out from the schematic. So let's do that now before I mess up. So we got the 4, no, you can't see it, I'll mark them off. We got the 4 diodes on, we got the 2 chips on, we got the 2 capacitors on, and I think the resistor R49, that 2 mega ohm resistor. Can't really read it very well, it's a bit blurry, this manual, but okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9 components. One, 2, 3, 4, 5, 6, 7, 8, 9. Right. Okay, good. There you go. Then let's put the let's see, what else do we need to test our circuit? I mean, we don't have to populate everything at once, but what would be good as a start to test is the NE555 and everything surrounding, because then we already should see this LED here blink. So let's put this missing resistor on, this one, and the LED, and see if it works when I give it 5 volt or so. Yeah, DC 3 to 12 volt it says. I wouldn't try that with 12 volt to tell you the truth, but this is what the manual says. So we need a 10 kilo ohm resistor, which should be a 10 with 3 zeros, so 103 as SMD marking. No, if you can't see that, but it says 103. So let's pick one from this belt, reel, whatever you call this, strip probably. And if you're wondering why my hands are all scratched up, that's the cat. That's the lab cat. Good, so that was 103. Goes to probably, can't read it, R48 I would say, which is there. So R48. Oops, too much. And place it, but in which order? Which direction? Doesn't matter, but I'm nitpicky. Which order did I place the other one? Can't see. I'm so short-sighted. Okay. Yeah. Like this. Yeah. Yeah, let's do one component at a time, otherwise I have more stuff floating away. Let's try to also heat from the top at the moment, but you can't see it. Where is my... at least should get it into the shot here. Let's try this. And usually probably hold this with a was almost okay. Maybe I can even go a bit higher, above 400 degrees. Then it would, you know, melt faster. But that looks actually quite nice. Right amount of solder, centered itself. It looks like I'm getting better doing this. So that was R48. Now we have one resistor, 330 ohms says the schematic, but they gave me, I think, 390 ohms. But I guess it should work. So, oops. Get one out. Nah, I think my pliers are a bit dirty. Also clean them with flux. So R50 goes here, and then there's the LED, which is at the output of the NE555. So again, give it a bit of paste, too much. And as you can see, the board is now already hot, so the paste more or less melts already when I touch the board with it. So 391. I should make sure I'm in frame here. And another try. Let's pin this down a bit until it melts. And it worked. This is much better than last week. So now LED, as it says, LED light emitting diode. So it's a diode, and I have no idea which direction, where's the cathode on these things. So I guess you have to get one out and try to measure it, and then I solder it on, and then we figure out that it was the wrong way around. Nah. Opening it is again a bit of a hassle. There you go. One LED coming up. And soldering it on in the right way would also be good. I mean, not with the light emitting bit to the bottom. So I think, yeah, so there's one side where it looks greenish, and the other side is silver. So that might give us an indication which side is what. So let me take the board away and we try to measure this. Here is our lovely tiny weeny LED, and multimeter, and now gentle. Nope. That did not work. Maybe my probe points are too big. Okay. Okay, let's try something else. So here I have my lily pad that I used also to repair the true STX. And it also has a LED on, so maybe we can see if there's also markings on there, which side is which. There it is. And funny story, when I got this, it was not working. I mean, the LED was not working, so I had to reflow R2 and D1 until it would light up. So the question is now, where is the cathode on these things? I don't know. That could slow us down a bit if we don't find out which bit's the cathode. Okay. Right. I mean, I have no manufacturing strip. What does the manual say? Quick check of the manual. No, it doesn't say either where the cathode is on this SMD LEDs. Okay, so there's a quick way and the slow way. Maybe I should just get a 470 ohm resistor. And here I have a dodgy crap 5 volt power supply. So we just grab a leaded resistor and try it, which side is which, before soldering on. So I have to get the microphone off and grab one of these resistors. 1 second. And here we are back again. Clip on the microphone. Of course I didn't find a resistor, so I have to see. I didn't find one in my scrap box, so I have to find one from my good parts box. So let's see, here we have a lovely leaded metal film resistors. Come on, focus, you bugger. There you go. So let's, I don't know, get one out here from the rail, grab it. So that's our plus. Now I would need a small prong for the other side. Bit of scrap wire somewhere. Here you go. And let's see. So we have 5 volt. We have 390 ohm resistor, and we have a tiny weeny LED, but still not making. Ah, that looks like it. Hooray. Okay. So now I've just burned my eye out. It's very bright, but yeah, this side is the cathode. In Germany, I always say usually the cathode is the short lead on a regular LED. So if you have one of these 5mm ones, and I always remembered it like, you know, the short one, as in the Kurzlead, the kurze lead is the cathode, and they both start with a K. This is how I remembered, but it doesn't help with SMD. So now get my glasses out. Yeah, so basically the thing, the side where it looks green is the cathode on these things. Good, so we can put that aside for the moment and go back to our development board. And don't flip it around. So the left side here was the green one. You can really hardly see it. It's tricky. So, and now zoom in, focus. I say it works much better with the Android phone as with the Action Cam. I mean, Action Cam is not made for macro shots, clearly. So, and then I guess one of these pads must be ground, and that's where the green bit, the cathode, should go. So let's see, from this to there, yeah. So the green bit should face downwards. Right, and we said we will hand solder this one. So I need a bit of solder. And then we need the LED with the green bit facing down, so like this, maybe. Oop. And since I want to slide in the LED from the side, I have to orient it that I'm coming from this side, heat the pad, slide it in, and the other side. I should have used a bit of flux there, but don't know. Okay, let's use the flux pen. Small dab. Clean the iron. Retin and one. Two. That was not working too well, did it? Try again. I think it's already evaporated. So, and after all this effort, we'll probably find out that I put it in the wrong way around, despite double and triple checking. What's the time saying with our stream? Nobody watching and talking to myself for 40 minutes. Good. So, ooh, I made a mess. No, just looked for a second as if the part moved, but it was just a bit of fluff from the paper. So, and now in theory we could give power to this thing and we should see the LED blinking. Maybe a last inspection for any bridged joints or so. Yeah, I'm not sure. Maybe we should reflow it. Let's see. If it doesn't work, we'll reflow it. Okay, so we have, oops. Let's see, can I just clip this on here? Oh, yeah. Let's give it a quick test and see what happens. Plus, minus. Ah, fantastic. Look at that. Good. So that means our NE555 is working and blinking. So now we can put the remaining resistors on. Let's see. There's 4 10 kilo ohm resistors. 61, 62, 63, 64, which are where? Somewhere here. 61, 62, 63, 64. Okay. But they're all next to each other. So when if I would put paste on and put the resistors on and put the hot air on, they will probably create a big mess. So how should we do this time? I don't know. Hand solder it or use the hot air station. But if I use the hot air station, I probably have to heat the whole board up 4 times. So it's okay. What we'll do is, for the sake of the experiment, we'll solder R64 with the hot air station and maybe 62, and the other 2 we hand solder. Then you can see the difference between hot air and my shaky hand. So those are again 10 kilo ohm resistors, so should have a marking of 103. There they are. Just always to see that I am showing what I try to do here. So okay, so those are 2 resistors placed, and then I would say let's try maybe try 410 degrees and 40% airflow and see if that is more agreeable. And now I have to move things so, like this maybe, yeah. Okay, heat it up. And where are my pliers to give it a gentle nudge? See, it's already moving around. Yep. Okay, that was too much solder on this one. So I'm gonna use this tip with the dimple again to take the excess off. Okay, it was also too much on, yeah, that one's definitely too much. Bit of flux. Where is my solder? Here is it. Solder, yeah, it's a fight. So, and let's see, can we fix this? Yeah. Right. Maybe zoom in a bit more. You can see the whole beauty of this mess. And we need more IPA. And yeah, looks okay to me. Then 2 more, and we said we want to hand solder those. And okay, I guess I can use the same tip. And yeah, it looks quite scary. This big tip and this small footprint, but it works, trust me. So that one is already tinned on this side. So let's tin this one. Right. Then maybe give it a bit of flux. And I'm completely out of focus here. And 2 more 10 kilo ohm resistors coming up. 1, 2. Where has the other one gone? See, that was 2. No, they lie next to each other. Out of screen. They ended up here. So one, let me slide in from this side, and the other one from the other side. So place it here. That was a bit an odd angle, or right. Fix this. Well, once they are all placed, we could just use the hot air station and let them, you know, recenter themselves, give it a bit of extra flux, because then there's no danger of the parts blowing away once they are soldered on, and the surface tension of the solder holds them in place. So yeah, maybe let's try that. So we don't have to be super neat here when we will reflow it afterwards. So let's see. Yeah, that was a bit too far. Maybe like this. Then, as you can see, this is highly inefficient way of building this kit, but I mean, it's for practice, so, and keeps your mind off things from politics and other nasty stuff going on in the world. So which side have I not soldered on yet? I forgot. Oh great. I just hear my beloved cat throwing up in the hallway, so that will be the, oops, see, I touched the wrong one. That was the one which was not soldered on. Yeah, fantastic. I'll have a cleaning session after the soldering session, cleaning up some cat puke. Ah, well. I think I've lost track which part I already had soldered on. Okay. Guess I have a cat puke distraction that upsets my steady hand. Good. So what do we do? If in doubt, always add more flux. And then try to clean this up before I clean my whole way. I hope the lab cat didn't hit the carpet. The tiles is always okay, but carpet is not good. So there we go. Fantastic. And my fiber cloth for cleaning up the IPA was too messed up, so now I'm using some towels, but it's messy. Microfiber cloth is much better because you don't get these paper strands. Okay, well, I would say they are on, maybe not super pretty. Yeah, come on. Yeah, now the cat is visiting, proudly showing what mess she has made. No. Okay, so what's left? We have put on the 4 10 kilo ohm resistors. So we still have 4 transistors in the corner. That was the cat again. Yeah, maybe in the if there will be a next stream, then I should have a second camera in the room where we can get the cat into the frame. Good. So 4 transistors missing in the corner, and then basically just resistors and LEDs. Well, the current limiting resistors for each of these LEDs. So here 67, 68, 66, 65, and then in this circle alternating always a resistor, a diode, a resistor, a diode. So maybe that won't be so interesting. Let's try the 4 transistors, and maybe also the diodes and the LEDs. What are you doing? Yeah, I heard that you puked into the corridor. I heard it. Okay, continuing. Right, so these transistors. Okay, maybe you should do it again differently. I think the cat wants me to throw a foam ball. That's her favorite pastime. When I throw the foam ball down the stairwell and from the top floor, and she just jumps and runs after it. Come on, don't destroy my resistor networks here. If you get your ball, I can throw your ball. So I'm not sure if it's a cat, maybe it's a dog. Good. So what did I want to do? I wanted to pre-tin these pads for the transistor and then try it a bit differently. So basically heat it without having the part placed and basically dropping the part on top of the solder. But as I don't know if that works, let's try it with the 1 transistor first. And if it works, we can do it with the other 4. So, and again, I was out of shot. I really have to keep an eye on my camera. So basically here, Q4 was the one that I tinned. And now let's use the GUI flux and get the transistor out. Come on. There we go. There it is. Let's put it on the other side. Okay, temperature wise, good question. What do we use here? Let's try yeah, let's keep 410 and 40% airflow. Don't know. Let's see if that works. And I have to grab my transistor before it blows away. Right, so. Nope, that was too early. Is this okay? I don't know. I don't think so. Maybe more flux. Yeah, see, it was somehow I think it's definitely liquid, but it's not self-centering. That works much nicer with chips. I think not the best way to solder a single transistor. I guess we'll do the other ones by hand. Maybe just reflow them afterwards with the hot air station. So yeah, it's obviously very hot now. I hope I didn't fry the transistor. No idea how heat sensitive these things are. Managed to destroy one of the picks when I tried to build the ATU 100 ATU for ham radio. So there was a also a fine pitch pick on, and I hand soldered it on, and then it was dead. So good. So let's do it differently on the other ones. Just tin one pad, and I'm not in focus. And then place the resistor and solder them down on this one pad, and then just solder the others. Okay, interesting. I got an extra resistor for everything, but I didn't get an extra transistor. So, oops. And there it goes, one thrown off. Yeah, and it's, of course, would be good to solder them on in the right orientation, not with the leads upside down. Let me get the thing back into the shot. I can probably delete this live stream. Nobody wants to watch my boring ramblings. Should probably try a calming Bob Ross-like voice, so don't make mistakes, just have happy little SMD soldering accidents. And there we go. Now, at least I have them all on the board, roughly where they should go. So let's start with this one. Heat the pad and slide it in. This is not good. Can't really see. Should maybe get one of these scope USB soldering microscopes. Oops, that was not good at all. More flux. And one resistor still pending. Over there. Yeah, this is not good because I cannot really put my head over the PCB because then the camera is obscured. So it's a bit tricky to see how off I am. Okay. Yeah. So slight readjustment necessary. Mind you, we could let the hot air station do that. But let's move this a bit up. Yes, and this one as well, because I really can't see if I'm properly placed over the pads. Yeah, that looks a bit better. Okay, so the remaining pins here, two at the bottom, and those two, and those two. Maybe I should also use a different tip. I should go back to this one. Let's use this tip. Yeah. So, yeah. Yeah, that's already too much solder again, I think. That was better. So let's see, how big of a mess did I make? Oh well. Oh well, oh well. It will all work, but it will not look pretty. So in theory we could use the hot air station now to give it a once over. Let's try that, see if that improves things. Can't see anything here, right? I really need to move the hot air station by 10 centimeters, so it's exactly the 10 centimeters are missing. Now the interesting question will be now, how badly have I damaged those transistors? That one pin, I don't think it's looking great, and I think it's also not centered yet. You see this one here, let me zoom in. Okay, it's full of goo because of the flux, but it didn't really self-center. Maybe it was too much solder already. Try to clean it up. Then you see that it's not pretty. It sits a bit too much on the left side. It will work, but that's the one we did with the hot air station. Amazingly, that looks still the best, but it was a bit of a pickle to get on. So what about this one here? And also does not look too good. Does look like it's not enough solder, and also sits a bit too wide, too much on the left side. And this one, has too much solder on 2 pins and not enough on 1. So yeah, what do we learn? I can't concentrate when I know there's a steaming pile of cat vomit waiting in the hallway. Good, then let's try to fix this. Okay, well, the too much solder should be possible to fix. So basically tin it. Zoomed in so much I can't find my transistor anymore. Okay, I guess so. Let's try with the flux pen. I don't know, the flux pen does not work as good as the goo for me. I don't know, it just instantly evaporates and is gone, and the goo lasts a bit. It's tacky, and see, it makes a sound and is gone. That did not work at all, did it? Okay, and let's try the tacky stuff. Better. Well, that was a bit too much solder now, but okay, zoom out a bit. Okay, so apart from my inability to properly solder, I think the camera setup works much better this time than with the first part of this stream. So clean it up. Maybe I will give it another go with the hot air station offline. I think it should be possible that this thing recenters itself. I don't know. It really also very much depends how many ground planes your PCB has. So I took the RT Mega off from the lily pad from this board. Let's have a look here, and that was working. Basically I set it to 350 degrees, 50% airflow. It was easy peasy. You heat it, you grab your pliers, you plug the chip off. Mind you, I think this board was leaded solder because all the solder joints were shiny. And then I tried the same basically with the true SDX board, and I was, frying away and had to increase the temperature to 375 in the end to get the chip off. So I guess, yeah, have to develop a feeling which PCB, which solder needs what temperature. Obviously, you don't want to fry just for frying sake. So basically as low as possible and getting the part off in a reasonable time. I guess that should be the aim. Okay, we have 4 transistors soldered, not very pretty. Let's tick them off. And we have 4 resistors to go and 4 diodes. So let's do those with the paste again. Maybe I was too worried with the transistors, and in the end it didn't do them any good because it took ages to solder them on. So for resistors coming up, yep, and place them in the paste. 1, 2, 3, come on, 4, okay, and hot air coming. Let's try the one here first. Yep, see as wandering around before it, zack, reflows. So the other one, maybe I hold it down with the tweezers a bit. Ouch. Yeah, obviously the tweezers are hot now. Idiot. Oh god. Well, that was to be expected, was it? If you heat your tweezers with 400 degrees, they reach the temperature. Okay. And number 4. Okay, that was a bit too much solder again. So let's fix that. on this one. Take the excess off. Shoop. And on this one, take the excess off. Oops, now you haven't seen it. Good. Well, I guess with a hot plate, this would be really easy peasy. You just place all the components, well, put the solder paste on, place the components, switch on your hot plate, and it will all magically sort itself out. But chances are, and we are most likely as hobbyists more having to do rework than populating stuff from scratch, so I guess knowing how to use a hot air station might be a useful skill. Good. Then what does the time say? How long is the stream going? Oh, 1:20. Okay, I didn't want to do another 2 hours because A, nobody's watching it, and B, how much can you learn from me messing up every single resistor? Probably not so much. So I would say we put 4 more LEDs, then we will see the 4 LEDs on the side blinking, and I'll do the ring myself offline. I mean, it's basically always the same, yeah. What I will probably do is solder all the resistors with the hot air station and paste, and do the LEDs manually with the soldering iron, because I'm too afraid that I will melt them with the hot air station. Okay, so we need 4 more LEDs, and we need to know where's the cathode on the PCB. I think it's on the right side because there's a bit of a thicker dash on the silk screen. So if you see here, it's a fine, you can't see it because I'm out of focus. Let me zoom out a bit. Oops, like this. So here on the silk screen you have the diodes, and on one side they have a bit of a thicker silk screen. So I think usually that should be no, not. Why not? Because I'm dumb. This is not. These are not LEDs that go to ground. These are the LEDs that are connected to the resistor, and the resistor basically pulls it to ground. So it's like a buffer stage, because a single output of the CD4017 has to drive 4 LEDs, and I guess no, even more. It's not. Yeah, has to drive 4 LEDs. And that would be a bit too much. So they put basically a diode after the output. So all those should be connected together. And each of the outputs of these diodes goes to one of our 10K resistors. So I don't know which one goes where. Okay, famous last words, maybe not. No, I was wrong. Right above there are the resistors and those outputs. So first, this is the output of the CD4070, pin 12. So all those are connected together. And then it goes to these resistors, and those resistors go to the transistors here on the side. So if I go here, then it might be one of, yeah, so here. So this one goes to Q4, and this one goes to nothing. Goes to Q3. This one goes to Q2. This one goes to Q1. So this is the base of the transistor. So the other side is then collector or emitter. All the emitters should go to ground. So let's see which one is this. This are the emitters. So the collector is the single pin on the top, and this is where our LED cathode should go. So basically from here to here, right, or from here to here, or from here to here, or from here to here. So basically, long explanation, the green side of the LED should be here on the right side. Okay, so let's get 4 more LEDs out. Or maybe one at a time. Let's see. And place it already in the right orientation. Like so. Green dot or green side on the right side, aligning with the fat marking on the silk screen. Oops, and now I've lost the diode. There we go, number 4 and 1. This one doesn't want to come out. Which side is the green dot? This one. Like so. Okay. Then I need the right tip again. And I don't know, tin. This one, it's a bit stubborn. Good. So then, master of the shaky hand. Let's try this, but only with my favorite add-on, more flux. Right, good. Then, bloody hell, I really need to replace this tip. It's already worn out, and I have a new one here, but I'm too cheap to ditch this one. mean, they are a bit expensive and they last quite a long time, but at some point you have to accept that they are gone. So now you get the idea. And of course, since I watched it at an odd angle, I didn't really position it properly. So let me try to fix that off camera quickly. Need just another centimeter or so, so that I can see the position on the pad correctly. I'm making a mess. Okay, so now the other side, more flux. 1, 2, 3, 4, and I probably get the fume extractor before I get a USB camera. Okay, let's zoom in and inspect the mess. So yeah, a small microscope would also be nice, but I don't know if I should spend 400, 500 bucks on something that I use not daily. So maybe one of these cheaper scopes would do, one of the full HD one, ADS something 302. Because I'm also wearing glasses, so using a real microscope is always a bit of a hassle here. You have to take your glasses off, you have to look into the two eye sets. I mean, stereoscopic, all nice and good, but don't know. Guess for my hobby purposes, a simple one camera LCD screen would do. And now zoom out again. Oops, this direction. And this is how it looks like. How bad of a job did I do? It's not, I mean, you see that it's hand soldered. And you also see that I didn't put enough solder on this one. Yeah, that is much better. But the good thing is almost everything is fixable. The only thing that's not fixable is if you fry with a big fat unregulated iron for 5 hours, then everything is gone. But you can still adjust things here with SMD, no problem. Good, so now let's get my patented magnifying glass and give it a last check. Yes, this does also not look super pretty here. Guess we'll give it another try. I think this one is not sitting flat, that's why it looks odd. So that's a candidate for another attempt with the hot air station to reflow. Maybe I sacrifice one of the LEDs and see. I mean, if they're made for surface mount, these LEDs, yeah, so they should cope with the heat. So it's not like PLA melting or something, but maybe I'm too paranoid. Don't want to kill LEDs. Okay, so let's see. The missing bits are basically, yeah, all the LEDs on the ring, and yeah, the resistors. Shall we give it a try now? Let's see. Well, I got them all on in the right orientation. In a way, it would be nice to finish this tonight, but we've already reached the 1 hour 30 minutes mark. So, should I go on? Well, I guess we can put all the resistors on. That should be quick. If I use the paste and do them in one go and not one by one. So let's try that. Too much paste. It's really not easy to get the right amount. I think I saw JBC. JBC has nice tools for everything. There's some kind of dispenser thingy where you clip your cartridge in and then you push it and it just gives the right, you know, amount for one pad. Right amount of solder paste for one pad. But knowing JBC, it will probably cost another $200. Come on. I need paste on this one as well. We have too much on this one. Well, let's see how big of a mess we make. And what we also can try is a bit of higher temperature. So let's try the, I don't know, 35% airflow and maybe 450 degrees. I mean, with resistors, they can take a beating. Maybe I'm just not yet reached the sweet spot for this solder paste with the hot air station. Two and three. And the next three coming up. Shoop. Oops, there is too much paste here. I already know I have to rework that afterwards. Nah. Come on. Now it's dropped off the cliff. Okay, 1, 2, 3, 4. We need 4 more. And they gave us 2 extra. In case I lose one in a minute. Oops. So, and my tweezers are dirty. Probably already have some paste on. Come on. Little resistor, you have to go there. And let me clean that off quickly. That one goes there. And now another one. Goes there. And one last missing. This is where I've lost one. Somewhere here you should still have a spare resistor. Did I lose one when I dumped them on? Or did I miscount? I thought I got... There it is. Still can count, it's good to know. I'm just blind. Okay. There we are. All the resistors are placed. And now let's try 450 and 35% airflow, and try not to burn my fingers, and grab the pliers and off we go. Fire. That works quite okay now. Just have to move the board a bit to the left because I ran out of pipe for the hot air station. Am I still in frame? Yeah, of course you cannot really see how it reflows, because I have to get the nozzle right on top, otherwise the parts drift off. Like here, they already drifted off on this one. I guess we can fix it. Yeah, and one resistor left. Yep, and we got them all on, but my dosage of paste was woefully wrong, so guess we fixed that with the normal soldering iron now. And make it a bit prettier. Everything the healthy dose of flux, and then I need the tip with the dimple. Initially I thought it was a complete waste of money, because I don't know if I miscalculated, but I thought I was expecting a bit of a smaller tip, but in hindsight it's exactly the right size. Okay, maybe one, I don't know which cartridge number is that. Well, I cannot tell you now. The number of the tip is on the cartridge. I have to wait until it cools down and I can take it out. But I think there's also smaller ones. I think this was the 2mm one or so, but maybe should have gotten this one size smaller. I mean, for resistors you really, I don't know, you don't really, it's okay for me to fix my blunders, but I guess it would be good to have one size smaller to fix fine pitch components, like when there's too much or not enough solder on. Anyway, it still works quite well to take excess off. I mean, the good thing about the hot air station is that the components somehow self-center, so it looks much neater when you let the hot air station, you know, heat up the stuff. So how does this look? Well, that one did not really self-center properly, but yeah, and now I've made a mess. Trying to fix it by heating both sides, idiot. Okay, well, I guess I should heat it up once more with the hot air station. But since the stuff is already on, I'll go down to 400 and 50% airflow, because now it's just about repositioning that dodgy bugger there. Yeah, and this is what you call tombstoning, when they basically, the component, you know, rises like a tombstone. But I think we fixed it. Okay, and now clean everything. And I'm not wearing my ESD bracelet, which is also bad, but since I've already put the chips on, I guess the risk is low. The only really nasty stuff is what I found out, that this PC Bright cloth, which says nicely in yellow color non-ESD cloth, which is basically a big joke. It's the most electrostatic cloth I found in the whole house. Yeah, you rub your hand twice over it and it starts to crackle. So I don't know why they give you that together with your PC Bright holders. I think they should have just left it out, or I don't know, gave you more of these plastic rings. It's really, I don't know, I have to get rid of it, because sooner or later I will wipe my electronic components with it, and I mean, as I said, it crackles when you touch it. Okay, so now we have all our resistors on, and the time says, well, in 10 minutes I probably will not manage to get all these LEDs on. So I would say maybe do one and call it a day then with this stream. I mean, that was definitely a bit more boring than last week, but the picture quality should have been better. And my hot air station training did not go as bad either, so making progress on all sides, and as I said, keeping my mind off the state of the world. Maybe let's put one LED on, and then you can just imagine how I do the other ones. The important bit is again to put it in the right orientation, which means, as we have learned, the green colored side should go to the fat dash. And now for these ones it should even work to measure, because those are all going to ground. So when I put my probe here on ground and tap here, basically all the green, the cathodes face outwards. So do I hand solder it or use the hot air station? No, I don't use the hot air station. I could tack it and then apply some paste. Maybe that works. I could maybe just tack it with the existing solder, or get a bit of on here and just tack it on lightly so that it doesn't, Yeah, see, should have used flux there as well. Okay, so it's slightly tacked, and now we could give it a bit of solder paste. 1 and 2. Yeah, and then have another go and see if that works or not. It works. And actually, that does not look half bad. Well, 8 minutes to go until I reach my artificially assigned deadline of only running a stream for 2 hours. Should we do the others as well, like this? I guess we could, yeah. Okay, let's try that. Let's try that. So give it. Give it just a bit of flux so that the tacking works. Then take one LED, place it like this, then tack it, and do it for all the others like this. I don't know. Just still trying to find out the quickest way to do this. But it would be nice to end the stream with the rotating light, wouldn't it? I'm pretty sure I get one of them wrong, just for fun. Oh, hooray! Now I've lost one. Bloody hell! This was not good. I guess that one is gone now. Successfully lost one LED. Not good. Oh well, let's see. Let's put the others on before I lose them as well. Maybe they gave us one extra again, and we are good. 2 to go, and oh, I still have 2. Okay, so I lost one, but there was maybe one extra. And flux has already made it off the board. Okay, so I've placed all the LEDs. Let's check if I got it right. Right, that looks okay. So let's try to tack them. I think that one is already placed, yeah. I make a mess. Maybe also not the best pliers here, I must say. Yeah. It's not lying flat. Okay, what the heck. I'll finish this stream with all LEDs soldered, how long it takes. And then I can move on to cleaning the cat vomit afterwards. It's not the best way to do this, but I have a bit of feeling in the finger if it doesn't sit flat on the PCB. I don't think this is the best pliers for this. Maybe I should get some ones with have a bit of an angle. I had this is already completely worn out. Yeah, okay. So next investment will be another batch of SMD pliers. It's not good. I'm not able to grab and push down with this. Yeah. Really feel it when I press with the fingernail that it starts to sit, only then sit flush on the PCB. Okay, so they should all be tacked. Now we can mess it up with the paste again. Which was the one we did already? D9 was the one we did already. So we can go a bit. Oh, we already had that one, yeah. That was the one we already had. Applied paste twice, not good. Let me wipe it off again. It's like doing cookies, you know, or doing your, when you do Christmas cookies and you do the icing, you just get lost in the moment. So I already went round one time. Okay, let's see. How does this look like? It looks like a real mess. Yeah. But we might get them all in one go. So, back to 40% airflow and maybe 425. Let's try this. I mean, they're all tacked, so in theory, nothing can go wrong. Famous last words. Press the button and go. That is too much solder, I think. Zack. Number 2. Number 3. I'm not sure if that worked very well. I mean, it all reflowed, but I think they all floated up a bit, so this one, yeah, ouch, it's really hot. That's why it's called Hot Air Station. See how many LEDs we fried with this brute force. Want to finish on a high note. Approach. There's probably 3 of them already dead now with this approach. Anyway, that's why it's called a soldering practice kit. So now we can look again and fix the excess solder. Let's see. I think my dosing this correctly is really tricky. First fix the outside. This one is blown off a bit. D2 is not positioned properly, I think. Yeah. Okay, and now the inside, which is tricky because I don't see it. I think maybe this one. And this one. Well, they're all on, but that one is off, and yeah. Yeah. Don't know how toxic this paste is, by the way. There's all these small balls that did not join the main pad. Well, it should be lead free, so it just cost me 2 years of my life and not 10 years, maybe. I don't know. And no worries, I'll wash my hands thoroughly after this. As somebody so rightly mentioned to me when I was rambling on about lead-free solder and leaded solder, it's not the lead that kills you, it's the flux which is unhealthy. So, don't know, somebody said lead melts at, I don't know, 1700 something degrees. So it won't evaporate and get into your lungs, but the flux is what's unhealthy. Mind you, the old leaded solder sometimes had really, you know, clouds of flux. So this is much, I mean, less smoke, let's put it that way. Maybe more unhealthy, but less smoke. Okay, so let's turn it round and inspection. Inspection, it looks dirty because I have little bits of my paper towel everywhere on the board. And D2 is not positioned nicely. D6 is maybe not soldered at all. So D2 and D6 need to be reworked. D2 and D6. D6 is here. And D2 is here. Oops, that was a lot of flux. So let's go back to the tried and tested setting that worked best so far, which is 445, I guess. And give it another heat cycle. I think this is what finally kills this LED. And D2 needs also. Yep. And I think now it sorted itself out. And we've reached, yeah, we went past the 2-hour mark. 2 hours, 11 minutes now, but I hope we can all have a laugh and it doesn't work. It's amazing how much abuse these PCBs take these days. I remember when I was a kid, okay, maybe I had a very crap soldering iron, that's a big, but I had lifted pads all the time. I mean, I don't know. But I was having, I was using a Vela Magna stud. I think probably rotten old tips, but it was actually quite nice. And it gave this satisfying clicks whenever the heater went on and off. That was quite fun. You can still get them today, but I don't know. Do they do Magna stud tips for lead-free soldering for the higher temperature? Because that's how somehow how it worked. You know, the tip heated up, and when it reached a certain temperature, then it, I think, lost. I don't know. Maybe I'm talking crap now, but I think there was a reed relay, and based on the temperature, the tip was losing the capability to be magnetic or something, and that's how the switch opened and closed. So it was robust as hell, but obviously no PID control loop. I should read it up on Wiki how that worked. I had one station like that, but it was so knackered that I had to let it go. Okay, and I think now comes the moment where we find out if it works or not. But what would also be nice is to have some proper cables on this thing to give it a test. I don't know. Let's just give it 2 small leads of wire. And quickly put that on. And then I can see what my cat has done in the basement. Okay. Quickly preparing 2 small leads for the final test. So, plus, minus. Not pretty, but quick. And that was nothing. Here goes nothing. Come on. Yeah, that's making the biggest mess with the last 2 solder joints. Huh? Unbelievable. Come on, do it half way properly. So, now, number 1, number 2, good. I don't know if anybody will watch this video, but as you can see, it's no rocket science, it's doable. This is just it's not my first attempt totally in SMD, but my first training kit. So basically, what have I done? I've touched up some parts on the true SDX so far, but so, and now is the moment of truth where we know if we have fried a few of the LEDs. 3, 2, 1. That looks okay, or let's see. Can maybe reduce the light here a bit, dim it. Yeah, this is what you want to see. So the 4 outer ones are working. The blinky one is working. And now let's see if we have any gap. This is working. This is working. This is working. This one, this one. This one is a bit dim. I think maybe fry that a bit. I think all is working. D2 is maybe got a bit too much heat, because it's definitely dimmer than the rest, I think. Okay, so light back up. That was the SMD Soldering Practice kit. Soldered with the Atten ST862D and my JBC C2 whatever soldering station. And I have more fluff here. Come on, go away. Right. So now I just have to figure out how to properly terminate the stream without losing the last 2 seconds of audio. Or maybe I just shut up and let it run for another 30 seconds and then press stop. Oh, I have 2 buttons. I have stop streaming and end broadcast. I guess I'll press end broadcast. So thanks for watching. I don't know if that was useful or not. You can leave a comment if you're interested in any follow-up. I thought about doing a stream about the true SDX and all the mistakes I made and how to diagnose errors and so on, but I don't know if that is useful for anybody else. But first I have to get it working. But it looks promising. I've replaced the VFO and I've replaced the ATmega, and now it finally seems to work. I was able to receive QSO in the afternoon, so things look much better than 2 weeks ago. Okay, have a good one. Have a nice weekend, everybody, and goodbye.